everyone, we're going to find the inverse of a rational function, verify domain and range, and find domain and range of both f and f inverse. If you've been watching the videos up till now, I suggest that you pause and try to do this on your own, and then you can just go through and check. So the first thing we're going to do is switch my f of x to y, and then switch the x's and the y's. Now go ahead and cross multiply. Get xy plus 4x. I'm just multiplying these two here. Equals 2y minus 3. You group your y's together, so it's going to be xy minus 2y, and I'm moving this 4x over. So it's going to be negative 4x minus 3. I'm going to factor out the y here, and I get x minus 2 equals negative 4x minus 3, and then divide. So you get y equals negative 4x minus 3 over x minus 2. And this is your inverse. Now what I suggest when you have something like this is to go ahead and pull out that negative, because it's going to make it a little easier when you compose these. Okay, so let's do the domain. Domain of f equals the range of f inverse. So the domain of f is all real numbers, but x cannot be negative 4. And the range, therefore, would be all real numbers, but y cannot be negative 4. And then for the range of f, that equals the domain of f inverse, because you just switched the x's and the y's. So we're looking at this one, and that's going to be x, all real numbers, but x cannot be 2. And then so the range is the same thing, all real numbers, but y cannot be 2. And now we're going to compose these with f inverse. And so my inner function is 4x plus 3 over 2 minus x. Now what I did on that previous one, we had f inverse, let me write that, is negative 4x plus 3 over x minus 2. And so what I did to get rid of that negative is I just moved it to the denominator. So I put it down here because the whole function's negative. And when I negated that, I get negative x plus 2. And then I rewrote it like that. It just makes it easier when you're trying to compose. Okay, so now that we got that, now I'm going to write down my outer function, which is 2 times x minus 3 over x plus 4. And I'm going to input my inverse, inner function, 4x plus 3 over 2 minus x. See how doing this little trick helps us out? Now all I'm going to do is clear the fractions by multiplying both the numerator and the denominator by 2 minus x. And what happens is this is going to cancel with that. So I'm going to go ahead and distribute here. That's going to be 8x plus 6 minus 3, and then we have to distribute that. This will be 2 minus x. Over, same thing, this is going to cancel. So you're going to get 4x plus 3 plus 4. That was that part, and then you distribute 4 times 2 minus x. And simplifying more, that gives us 8x plus 6 minus 6 plus x, or plus 3x, over 4x plus 3 plus 8x minus 4x. Oh, this is plus 8, sorry. Plus 8, that's what happens when I don't look what I'm doing. Okay, minus 4x. So basically, let's see what we can cancel out. We can cancel those out. That zeroes out, that zeroes out. So you get 11x over 11, which equals x, which is our desired result. Now let's go the other way. And we have f inverse composed with f of x. So it's going to be f inverse, and my f of x, my inner function, is 2x minus 3 over x plus 4. So f inverse is negative 4. It's my outer function. Everywhere there's an x, I'm just going to leave parentheses. And I have x minus 2, and I'm inputting my inner function. So that's going to be 2x minus 3 over x plus 4. 2x minus 3 over x plus 4. Now, you can go ahead and distribute this, but what I'm going to do is clear the fractions here and the numerator and the denominator by multiplying this by x plus 4 times x plus 4. And when you distribute here, you get negative 8x plus 12. This will cancel when you distribute, and then you get minus 3 times x plus 4 over, this is going to cancel when you distribute. You just have 2x minus 3 minus 2, and you have to distribute that, x plus 4. Clean that up, and you're going to get negative plus 12 minus 3x minus 12 over 2x minus 3 minus 2x minus 8. So let's see what we can zero out. The 12's here, the 2's here. So we negative 11x over negative 11, and that equals x. So we're good. They are indeed inverses of each other. Thank you. Have a nice day. Bye-bye.